Chemical kinetics questions from last year CBSE board exam 2023. Which of the following is affected by a catalyst? Delta H, delta G, EA and delta S. A catalyst cannot change the enthalpy or Gibbs energy or entropy, but a catalyst reduces the activation energy by taking an alternate pathway for the chemical reaction. So it affects the activation energy. Our option is C. The order of the reaction H2 plus Cl2 gives 2HCl is 2103. H2 plus Cl2 gives 2HCl. It's a photochemical reaction. All photochemical reactions are zero order reactions. Our option is C. The slope in the plot of concentration of R versus time for a zero order reaction. Zero order reaction, we can plot concentration against time, and the slope is k is equal to negative slope, or we can write slope is equal to minus k. So our option is B. The rate of a reaction A plus B gives product is given by the equation R is equal to K into concentration of A raised to 1 and B raised to 1. Here B is taken in large excess. That means rate of the reaction does not depends upon the concentration of B. So it depends upon only the concentration of A. So we can write order is the sum of the powers of the concentration terms. Since it depends upon only concentration of A, its order is 1. The half-life of a reaction is doubled when the initial concentration is doubled. The order of reaction is, for a zero order reaction, we can write T half is equal to R0 by 2K. And when the initial concentration is doubled, that means 2 times, automatically we know the T half will become 2 times. So this is happening for a zero order reaction. So our option is D. The half-life for a zero order reaction is equal to initial concentration by 2K. So where R is the initial concentration, here 2K by R, half into K by R square by 2K, R by 2K. So our option is D. R by 2K or R0 by 2K. Here initial concentration is mentioned as R. In a reaction, the initial concentration of the reactants increases fourfold and the rate becomes 16 times its initial value. The order of the reaction. So generally we can write the rate law equation, rate equal to K into concentration of reactants raised to N. And here it's mentioned concentration of the reactant increases fourfold. So we can write K into 4R raised to N. So we know if you substitute N equal to 2, that is equal to K into 4R raised to 2, that is equal to 16kr square. So when we substituted n equal to 2, it became 16 times. So the order of the reaction is 2. The number of molecules that react with each other in an elementary reaction is a measure of activation energy, order, stoichiometry, molecularity of the reaction. So it's molecularity because molecularity is the total number of reacting species taking part in an elementary reaction that must collide simultaneously to bring the effective chemical reaction. For the reaction A plus 2B gives C plus D, the rate law is given by R equal to K into concentration of A into concentration of B raised to 2. The concentration of A is kept constant while that of B is doubled. So we can write R equal to K into concentration of A into concentration of, here instead of B we can write 2B raised to 2. That is equal to 4 into K into concentration of A into B square. So here we can see the rate becomes 4 times. So it a quadruple. Option is D. If the initial concentration is reduced to 1 by 4 in a zero order reaction, then the time taken for half reaction to complete. So T half is equal to R0 by 2K. This is the equation for a zero half-life equation for a zero order reaction. And it is mentioned if the initial concentration is reduced to 1 by 4. So second case R0 by 4 divided by 2K, that is equal to R0 by 8K. So when we compare T half, we can see R0 by 2K into 1 by 4 is equal to R0 by 8K. That is, it reduces to 1/4. For a reaction 2A gives 3B, the rate of the reaction minus dA by dt is equal to. So 2A gives 3B, we can write minus 1 by 2 dA by dt is equal to plus 1 by 3 dB by dt. That is minus dA by dt is equal to 1 by 2 into, so we can multiply 1 by 3 into 2. When we cross multiply 2 by 3. So plus 2 by 3 dB by dt. 1 by 3, 1 by 1 by 2 will become 2 by 3. So minus dA by dt is equal to plus 2 by 3 dB by dt. So our option is B. For a zero order reaction of the type A gives product, the rate of the reaction can be expressed as, generally we are writing K is equal to R0 minus R by T. Here reactant is A, so A0 minus A by T. So our option is A. The following experimental rate data were obtained for a reaction carried out at 25 degrees Celsius. Initial concentration of A and B and rate is also given. We have to calculate the order with respect to A and B. Here options are given. So when we write rate expression 1.89 into 10 raised to, from the given data, we can make equation 1.89 into 10 raised to minus 4 is equal to rate equal to K into concentration of A raised to X into B raised to Y. So concentration of A raised to X into B raised to Y. Here, first case, concentration of A is given as 3 into 10 raised to minus 2. 3 into 10 raised to minus 2 the whole raised to x into, and first case the concentration of B is given as 2 into 10 raised to minus 2. 2 into 10 raised to minus 2 the whole raised to y. So let us take this as equation 1. Similarly, the second case, rate is given as 1.8 into 10 raised to minus 4, that is equal to concentration of A is same, 3 into 10 raised to minus 2 the whole raised to x into concentration of B is given as 4 into 10 raised to minus 2. 4 into 10 raised to minus 2 the whole raised to y. So that is equation 2. So when we do equation 2 by 1, left hand side we will get 1.8 into 10 raised to minus 4 divided by this. It will be equal to 1. K and K cancel. The concentration of A term will be cancelled. So 4 into 10 raised to minus 2 the whole raised to y divided by 2 into 10 raised to minus 2 the whole raised to y. So when we divide, we will get 2 times. So 1 equal to 2 raised to y. So 1 we can write 2 raised to 0. 2 raised to 0 is equal to 2 raised to y. Therefore, y is equal to 0. So the order with respect to b is 0. Similarly, let us write the third equation. 7.56 into 10 raised to minus 4 is equal to k into 6 into 10 raised to minus 2 the whole raised to x into b is 4 into 10 raised to minus 2 the whole raised to y. Now let us do equation 3 by 2. So 7.56 into 10 raised to minus 4 divided by 1.8 into 10 raised to minus 4, it will become 4 times. K and K cancelled. 6 into 10 raised to minus 2 divided by 3 into 10 raised to minus 2, it will be 2 raised to x. And y term also cancelled. So 4 means 2 square is equal to 2 raised to x. So x equal to 2. So order with respect to A is second and order with respect to B is 0. So our option is C, second and 0. For a zero order reaction, the unit of rate constant and rate of a reaction are same. So that's correct statement, because for a zero order reaction we can write rate equal to K into concentration of reactant raised to 0. Any quantity raised to 0 is equal to 1. So rate and rate constant are equal. Then reason, rate of a reaction for a zero order reaction is independent of concentration of reactant. That is correct statement. Rate of a reaction for a zero order, it is independent of concentration of reactant, that we can see from the rate law expression. So both are correct. Assertion and reason both are correct statements. Since we can say the rate of the reaction, it is independent of concentration of reactant, the unit of rate and rate constant will become equal. So we can say option A. Even CBSE has given mark for option B also. Next, the unit of rate of a reaction is same as the rate constant for it is related to the previous question for a zero order reaction. Next question, order and molecularity of a reaction are always same. Always, that's not correct, because order is an experimentally determined quantity. It can be 0 or even fraction, but molecularity cannot be 0 or even fraction. Complex reaction involve a sequence of elementary reaction and the slowest step is rate determining step. That's correct statement. So assertion wrong and reason correct. Our option is D. The molecularity of the reaction H2 plus Br2 gives to HBr appears to be 2. So that's correct statement, because both the molecules are involved in the elementary reaction. So assertion and reason both are correct statements, and reason is the correct explanation of assertion. Half-life of a reaction is the time in which the concentration of the reactant is reduced to one half of its initial concentration. That statement is correct. That's the definition of half-life. In first order kinetics, when the concentration of reactant is double, its half-life is double. That's wrong statement, because for a first order reaction, T half is equal to 0.693 by K. First order reaction does not depend upon concentration term. So assertion correct and reason wrong. Our option is C. Order of a reaction is applicable to elementary as well as complex reaction. That statement is correct statement. For a complex reaction, molecularity has no meaning. That's also correct statement, but reason is not the correct explanation of assertion. Our option is B.